So a customer came to us and they said, can you make a 360-degree version of your laser scanners? To which I initially said no, it'd be impossible, because the amount of copper that we fit into these laser scanners to get the performance we get is an amazing amount of copper in the first place, and I thought that there would be no way. We basically need to get an equal amount of copper and phase it by at least 90 degrees. And I thought that was impossible, but thought about it for half a year and then discovered a way that we could do this. It's basically a geometry problem. How are you going to fit more copper into this thing? Eventually figured that out, and then about another year later figured out how to fit yet another 50% more copper into it. So we have refined this idea, but what we've got here as a result of this R&D is a motor that's capable of 360-degree rotation and positioning anywhere within those 360 degrees. So it can run continuously, or it can stop. It can run forwards, backwards. It can position over any range of angles, and has a very precise position sensor on the back, which is capable of 17-bit precision within that 360 degrees. And the acceleration, what really separates galvanometer scanners from every other motor in the world is high acceleration. So of what would be considered to be a high torque to inertia ratio in the world is like 250,000. So if you can get 250,000 radians per second squared of acceleration, that's considered to be like super high in the motor world. And that's only done by what are called coreless motors, these kind of moving coil motors. Well, the Saturn IX and also our continuous rotation motor has radial acceleration of 15 million radians per second squared. So much, much, much higher than would be for a typical really fast motor. So these are super fast. Yeah, so this motor here is capable of going from zero, from a dead stop, to 120,000 RPM in only 1 millisecond. And capable of going from 120,000 RPM back to zero in another millisecond. So super fast, super high acceleration, and so that's kind of what we do here. Everything we do here is specialized, and everything we make here is not made by anybody else. So it really is kind of single source products, very highly specialized. And so to drive these motors and scanners, what we have is several servo drivers. One of them, and our most popular, being the Mach DSP. The Mach DSP has a floating point DSP processor running at 450 megahertz. We digitize 8 signals simultaneously with this. We digitize command, position, coil current, and coil voltage for 2 axes. So this one motor can run 2 axes, and we do it at up to 200,000 samples per second. It's really fast. In addition to that, this servo driver also samples all of the power supplies and the temperature of the board, and can also sample an external temperature. All of these sampling being done at much lower, like 10 times per second, because that's not so important, these other quantities. But this is a very versatile servo driver, fully digital. You drive it with a digital command signal, and there's also the ability to have TTL inputs and outputs so that the board can both be controlled by and also control external things. So now what's typically done in the world, like this is a more typical servo driver that would be kind of out in the wild and that has served the optical scanning business for the last about 45 years, believe it or not. It's an analog servo driver. You notice that there's a lot of pots on this thing, and to tune this thing, it really takes an expert that has a lot of training, because there's so many different combinations of ways that this thing could be adjusted. The possibility of getting it right is only happens with a super seasoned professional. So that actually represents a problem for the industry, because there's only so many of these super seasoned professionals out there. But this is an analog servo driver. It has the shortcomings of an analog product, and like I say, these things have been in use for the past 45 years. It is now the 2021, and optical scanning really began in about 1976. So people are still doing it the same old analog way. We have this digital product right here. We also have another couple of servo drivers here that are analog as well. So for people who do not need the level of sophistication of this, for things that require a smaller, more compact package, or a lower power supply requirement. We have this other servo driver here. It's the size of a credit card, and not as many pots, and this also is a 2-axis laser scanning servo driver. We also distribute power supplies too. This is not one of them. This is a custom 200-watt power supply I had made, but we have the power supplies that we typically sell to customers are smaller. And some of these are used in, like say, laser display products. Here's one of the laser display products that's just coming on the market right now. It's a portable laser display system that can be used with remote control or even apps and that sort of thing. As you see here in this little book stack here, there's a #1 best-selling book available on Amazon.com, Laser Scanners. It's written by me. It is the only book that covers laser scanners to the degree that this covers it, and yet it covers it from a very high level. So it means that you don't really have to be a PhD to understand everything that's going on in this book. So that's kind of an introduction to what we do here and our product line, how we control the scanners, and kind of gives you an overview of the kind of things that are going on. And there will be follow-on videos that are going to be a lot more specific to kind of the motor technology and servo technology and some of the other things we've got going on. So.